Alrighty, day 4 of Algebra 1. Solving inequalities with variables on both sides using the distributive property. So, first thing about this is that I want to talk a little bit more about what exactly is going on with these inequalities. So before I even get into all of that, I just want to talk for a little bit about that. So there's 4 different ones that you could possibly run across. And they look like that, okay? So a lot of times people get confused. I know even when I was in school, I got confused about, is this greater than, is it less than, or what is this, okay? So this always opens up from here to whoever is bigger. Even if the item is bigger on the opposite side. Notice how it's always opening up to the bigger one. When I was in school, they used to tell us that it was an alligator, and it always wanted to eat the bigger thing. Now, this also works with the ones that have that extra line, as I like to call it. Okay? So let's talk a little bit about what exactly this means. Okay? So I'm going to write down just a few random things. Okay, so let's talk about what this means. It's opening towards the A, so A is bigger. Well, I'll just make that simple. I'll go ahead and highlight the ones that are bigger, okay, just to make our lives a little bit easier. Okay, so I highlight the ones that are bigger. So here it says A bigger than B. Now that's a weird way to say it, right? But it's A bigger than B. The appropriate way to say it would be A is greater than B. But in my mind, when I see that, I say, oh, A is bigger than B. So next one. C is smaller than D. Now, you might ask, well, why didn't I say D is larger than C? Well, they wrote C first, and we always read from left to right. So I'm going to go ahead and read from left to right. So C is smaller than D. I would also say C is less than D. That'd be my appropriate way to say it. Now, take a look at the next one. E bigger than F. But it has that extra line. So really, if you kind of think about that extra line, sometimes in older calculators, you'll see them write it like this instead of this. And even for this one, they might write it like this. The reason is that means 2 separate things. It means E is greater than, or it can also be equal to F, okay? So my provincial way to say that would be E bigger or equal to F. And the proper way to say it would be E is greater than or equal to F. Okay, next one. G smaller than H. Okay, so I would read that and I would say G smaller or equal to H, right? But my proper way to say that would be G is less than or equal to H, okay? So just kind of keep those in mind. I know it's kind of a weird concept, and like I said, when I was in school, I used to get super confused about, is this greater than, is this less than? So I just kind of think about it as, which direction is it opening? It's opening towards the bigger one. So if it says A and then symbol B, I can say A is bigger than B, right? So I automatically know A is bigger. So then if somebody asked me to state that in a mathematical way, I would just say A is greater than B. Okay, let's go ahead and get on to today's notes. So, the other thing that I would like to mention about inequalities, and let me go ahead and add an extra page here. So the other thing that I wanted to say about inequalities is that whenever they're involved in an equation, and I'll just say equation, inequality of some sort, the rest of the equation. If at any time on any step I multiply or divide both sides by a negative number, I must flip the symbol. So let's say, for example, my first step was plus 5, right? And then I got an equation, and I answered that, and then I would look at my symbol and I would ask myself, did I multiply or divide both sides by a negative number? If it's no, it stays the same. If it's yes, it flips. This is a no, stays the same. So then my next step, let's say here, I multiplied everybody by -2, right? Okay, so I got my new answer. I solved it just like a normal equation. But when I get to this symbol, I ask myself, in this step, did I multiply or divide both sides by a negative number? And I say yes, so then I change the direction. Okay? All right, so today's notes. So, we saw inequalities, make that a little bit bigger, the same way we would solve equations, as you saw earlier, with variables on both sides, with 2 exceptions. So, we want to distribute on both sides, right? That's exactly like a normal equation. We could draw our line in front of every sign. We need to combine like terms. And we need to get all of our x's together. So when we were talking about equations before, it didn't matter. I always said move the smallest one so you don't start creating negative numbers. Now, here's the deal with inequalities. Yes, you can still do it the same exact way, but you might end up with an answer that looks like this, right? And you might be tempted to say, oh, x is less than or equal to 1. No, it's not. I always have to look, imagine this is my eye here, I always have to look in the direction of x going the other way. So this would actually be x greater than or equal to 1. Those two things are what we would get. But since we want to stick with appropriate math and we want to make sure and make this as easy as possible, we want to make sure we always move all of our variables to the left side, okay? This only applies to inequalities. So I'm going to get the variable on the left side of the inequality symbol. Lastly, of course, I'm going to use inverse operation, my opposite, to isolate my variable to get it alone. Now, super important, golden rules inequalities. Anytime I multiply or divide both sides, it's got to be both sides. It can't just be I distributed a -2 on the left side. It's got to be I did this both sides of an inequality by a negative number. You must flip the symbol to keep the inequality true. Okay? You have to keep it true. So, this first one, I'm going to solve it 2 different ways. One of them I'm going to move to the left only, and the other way I'm just going to solve it like I would just any other equation, okay? Just so you can see the difference. All right, so let's go ahead and do this. First thing I do is I look to see any distribution, no. Any combining like terms on left side, right side, no. Okay, so now I need to get my x's together. So over here I see a -3x and a -x, but that -x is on the right side, so I want to get it to the left, so I'm going to add it. Okay. Now, I automatically put in the symbol, but I still have to ask myself, did I multiply or divide by a negative number on both sides? No. So my symbol stays the same. Okay, next step. I need to start isolating my variable, getting this guy by himself. I'm going to do exciting move, great divide, every single time. Whoever's not attached goes away first, and whoever is attached goes away last. So I'm going to go ahead and move this 2. And I ask myself, did I multiply or divide by a negative number on both sides? No, I didn't, so my symbol stays the same. Now I'm going to go ahead and do my great divide. And I ended up with this. And I asked myself, did I multiply or divide on both sides by a negative number? The answer is yes. So this time, I flip my symbol. And I have an answer exactly the way that it would look on a test. Exactly the way that it would look in a textbook. However, I could have went a completely different way, right? Let's say that I messed up and I totally forgot that I wasn't supposed to move things around in any direction, that I was supposed to move it to the left, right? So I'm going to rewrite the equation. So I saw this and I said, oh, well, that negative 3x is smaller, so I'm going to go ahead and move it over. And I ended up with this. Did I multiply or divide by a negative number? No. Symbol stays the same. All right, now I need to go ahead and do my exciting move, great divide to get that x by itself. I'm going to move the 10. And because I did not multiply or divide by a negative number on both sides, don't need to change my symbol. Then I can divide both sides by 2, my great divide. And I end up with this. And I ask myself, did I multiply or divide by a negative number? No. Okay. Now, if you notice, these two guys are mirrors of each other. So if I use my eye and I look in this direction, it should look exactly like it would from that direction. Okay? So this confuses quite a few people. Okay? So I would highly, 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 highly suggest that you always do it in this format anytime you see an inequality. Always. It just makes your life that much easier. Okay? All right. So next one, example number 2. And this one I'm only going to do in the appropriate way. So first thing, I'm taking a look at all of these different things they have up here. I see a parentheses. I'm going to get rid of that. I don't like dealing with those. So I'm going to distribute this negative 4 times negative 6, 24x, negative 4 times positive 1, minus 4 plus 1, negative 2x minus 29. Now, here's where it gets a little fishy. A lot of people would say, oh, I multiplied by negative 4. Let me go ahead and change my symbol. No, I did not multiply on both sides. I only multiplied on one side. So this stays the same. Okay, now I'm going to go through and I say, all right, I need to combine any like terms. I only see one set that need to get combined. So I'm going to copy everybody else over, go ahead and perform that operation. And then I ask myself, did I multiply divide by a negative number on both sides? No, symbol stays the same. Okay, I'm going to always move all my guys over here. So I don't care what's going on with that 24. What I care about is what's happening over here. I see that's a negative 2x, so I'm going to add 2x. And I ended up with this. I asked myself, did I multiply or divide on both sides by a negative number? No. Symbol stays the same. Okay, next thing. Exciting move, great divide, right? Because I have something attached to x, something not attached to it, all on the same side. So first thing, I'm going to go ahead and get rid of what is not attached. I'm going to add my 3. And I ended up with this. Did I multiply or divide by a negative number? No. So my symbol stays the same. Divide by 26, my great divide. And I get x has some kind of relationship to negative 1. symbol does not change because I didn't multiply or divide by a negative number. Okay? So, that was nice and simple and easy. But sometimes people might ask you, well, what does that look like on a number line? And I don't want you to be shocked when they say that. So, let's imagine I drew a number line, right? Zero's usually in the middle, and we got a couple of them heading on out in both directions, right? So it'll be 1, 2, 3, -1, -2, -3. So, if I was to graph this on a number line, I would say, okay, so x has some kind of relationship to -1, right? So first I'll start here. I'll look for -1. I put a circle on it. I do not fill in the circle. And then I say, all right, is x smaller than -1 or bigger? It says it's smaller. That means that covers everybody heading out in that direction. Then I look to see, does it have the extra line, the equal symbol? It does. So I fill in my dot. And that's how you graph it on a number line. Very simple. Extra line, fill in your dot. No line, don't fill in your dot. Smaller than, arrow, heading out to the left. Bigger than, arrow, heading out to the right. So just as a reference, I'm going to go ahead and write out what those should look like, just so you guys can get to see it, because we're not going to really get a chance to cover that too well. And I usually like to make the very, very shortened form of these, where I don't write in all the numbers, and I just write in whatever the number is in the middle, just to make my life a little easier. Okay? So first one, x bigger than, don't fill it in. X bigger than, equal to, fill in, off to the right. X smaller than, off to the left, no filling. X smaller than, equal to, fill in, off to the left. Okay? Notice, only 4 different kinds you can have. Super simple. Okay? But I just wanted to make sure that just in case that ever comes up, you already know what's going on. All right, let's look at our very last example for the video. So here we got a lot of parentheses, lots of random stuff going on, this like really super long negative sign there, and another one over there. Like, I don't know what was going on with that, but that's okay. Let's go ahead and try and solve this one. So first thing, I need to go ahead and distribute. That negative, to me, means a -1, right? So everybody on the inside gets multiplied by -1, which essentially just sign positive to negative, negative to positive. 2 minus 11x plus 4. And let's do the same thing over here. 5 minus 24x plus 40. Did I multiply or divide by a negative number on both sides of the equation? No. Symbol stays the same. All right, now I look at my right side, I look at my left side. Oh, there's stuff all over the place. I need to start combining like terms. This is too much to deal with. So I'm going to look over here, and I say, all right, well, there's these numbers, so I see my x's are going to change, right? We always go in standard format, and I go ahead and combine those numbers. I look over here, all of my x's are fine, they're already combined up, but I do see these numbers here. Let's go ahead and combine them. And remember, I like to cross them off just to remind myself that I already did it. Did I multiply or divide by a negative number on both sides of the equation? Nope. So I'm going to go ahead and just write in my symbol exactly as I see it. Now I'm going to go ahead and start moving x's. So, like I said, normally I would say, oh, who's smaller? Here, I don't care. I'm just going to put a highlight over here to remind myself I need to move everybody over there. So, doesn't matter what this guy is, I'm going to do the opposite and move him over. And I ended up with this. I asked myself, did I multiply by a negative number? No, symbol stays the same. Next step, side to move, great divide. I'm going to move whoever is not touching my x. I'm going to go ahead and highlight it. Everybody else with that highlight on the same side needs to go away. So I'm going to take away my 6. 13x 39. Did I multiply or divide by a negative number on both sides of my equation? No. So my symbol is going to stay the same. Lastly, great divide. Let's divide by 13, which is usually super ugly. But 13 times 3 is 39. So x and 3. I asked myself, did I multiply or divide by a negative number on both sides of the equation? Nope. So my symbol stays the same. Here's my answer. If I wanted to just go ahead and put that on a line, just to make sure I understood the concept, that would be 3. And I would say x is smaller than. So it would look like that. All righty. So good job on getting everything done today. Go ahead and finish up your assignment. Let me know if you have any questions.